Okay. See, where is this? So this is the inlet velocity triangle I am drawing. The blade shape is like this. Okay, blade shape is like this, and rotor is moving in this direction. This is a omega. Okay, and this is V1, and this is VM1, and this is VR1. So, and from this to this is V1, and from this to this, it will be the U1. Okay, this is inlet velocity triangle. This is alpha 1. This will be the beta 1. And next, outlet velocity triangle. This is the inlet velocity triangle, whatever I have drawn. And next is outlet velocity triangle. So the blade shape at this outlet tip, ಇದು ಸೈಡ್ ಇಲ್ಲಿ ಹೊರಗಿನ ಸೈಡ್ ಈ ಬ್ಲೇಡ್ ಶೇಪ್ನ ಸ್ವಲ್ಪ ಚೇಂಜ್ ಮಾಡಿದೀನಿ ತಡ್ರಿ, ಅಂದ್ರೆ ನಿಮ್ಗೆ ಕ್ಲಿಯರ್ ಆಗುತ್ತೆ. This is 1, this is 2. Now this portion I will draw here the velocity triangle. For that, this is VR2, and this is the angular motion. Okay, that is the angular motion. Then this will be the U2, V2, and motion, and this is V2, this is VR2, this is VM2, if this is alpha 2, then this will be the beta 2, and this is VU2, and this will be the up to this, that is U2, up to this point. Okay, here it is the cover. If you extend it up to that point, it will be the VU2, and this is VR2, like this. The blade shape is like this. Okay, so if U1 is greater than V1, then these are the velocity triangles. Then if condition, if U2 is greater than, sorry, if VU1 is greater than U1, if VU1 greater than u1, then the velocity triangle will changes. So that velocity triangle I will draw here. See the rotor blade I will show here. So this is V1, that is entering a station. This is V1, and it has two components, that is horizontal component, that is tangential component, and the radial flow component, or else only flow component, simply radial component. And this VM1, VR1 I will draw here. This is, and the distances I will write from this to this. It is V U1, that is, I have written wrong, that is U1 from this point to this point, that is V U1, and this is V1, and angle of that is alpha 1. This is VR2, VR1, and this is VM1. This is beta 1. And now the outlet velocity triangle. Okay, outlet velocity triangle. If this is a blade shape like this, if the outlet velocity triangle like this, at the outlet blade tip, if it is like this, draw here. Then this will be the, just a minute. Okay, the blades I'm showing this. Then this will be the V2. This is the VR2. Okay, if this is the rotation, okay, that is the rotation. Then we should show like this. This will be the VR2, omega, and then the V2 rotation in this direction. Okay, this will be the V2 here somewhere. Otherwise, if you are confusing a V2, I will draw here from this line, and then I will draw the components. I will draw the components now. Okay, I will draw the components. This is VR2. This is V2. This is VM2. This is VU2 up to this, and This is u2, and this figure you can also draw like this. In the another fashion also you can draw. I will reverse it. Okay, I will reverse it. This is VR2 like this. VR2 the same thing, and parallelly I will draw here. This is the point. Consider this. ಅದೊಂದು ತಿರುಗಿಸಿಟ್ಟಿರುತ್ತೆ ಕೆಳಗಡೆ. Yes. And alpha 1, alpha 2, this is V2, this is VR2, this is beta 2, alpha 2, and this is U2, and this is VU2. Here I have done some mistake, but nobody has not noticed. That means you are not understanding VM2, and here I have done some mistake, that is you nobody has noticed. It is not from this point to this point, it will be from this point to this point. Is okay, it will be from this point to this point. This is u2 here, and here also I have done mistake. See this one, it is written in the middle here. Okay, I have written wrong here something. This thing I will clear it. Okay, this is v2, this is vr2, this is alpha 2, this is beta 2. See one thing that I have just rotated it and positioned like this. Okay, and even you should not bother that right now if you are not understanding. I think some concepts at least you will come to know now. When I am solving the problem, that time you will understand still more clearly. This is inlet velocity triangle, and this is outlet velocity triangle. Okay, these are different velocity triangles, whatever I have shown. So both are different shape. Okay, both are for different conditions. If u1 is greater than vu1, then these are the inlet and outlet velocity triangles. If vu1 is greater than u1, then these are the outlet velocity. These are general velocity triangles. Now, for the analysis purpose, for you would alternate form of Euler's equation. Okay, I will clear these things. This one is not required for me, so I am clearing. Right now it is not required. Have you taken the screenshot of that? Whether the screen is visible or not? Screen ಕಾಣತೈತೇನ್ರಿ ಎಲ್ಲರಿಗ? ಕಾಣತೈತಿಲ್ರಿ? Okay, fine. See, and now I will go through these are the general velocity diagrams. Now I will discuss regarding the Euler's uh, alternative form of Euler's energy equation. This is important from now onwards. This is derivation, they will ask the question. Alternative form of Euler's energy equation. Now, from outlet velocity triangle, I will write that from outlet velocity triangle, from outlet velocity triangle. Here, look at this outlet velocity triangle. I will name those terms O, A, B, C. Okay, I'll name this O, A, B, C. I have named from outlet velocity triangle. See, this is the blade and they are rotating like this. Okay, those things. This one outlet velocity triangle, this is. Here you can apply the Pythagoras theorem now. Vm2 V2 square equal to Vm2 square plus Vu2 square. V2 square equal to Vm2 square plus Vu2 square. Now you can write Vm2 square is equal to V2 square minus Vu2 ಸ್ಕ್ವೇರ್. ಇಲ್ಲಿ ನೋಡ್ರಿ, ನಿಮಗೆ ಈಗೇನು ತಿಳಿಲಿಲ್ಲ ಅಂದ್ರೆ ಅಟ್ಲೀಸ್ಟ್ ಇದೊಂದು ಫಿಗರ್ ತಕೊಂಡು ಈ ಡೆರಿವೇಶನ್ ನೋಡ್ರಿ, ಉಳಿದಿದ್ದು ಬಿಡ್ರಿ. ಓಕೆ, ಇದಿಷ್ಟು ಡೆರಿವೇಶನ್ ಕಲೀರಿ, ಇದು ಇಂಪಾರ್ಟೆಂಟ್. ನಾಳೆ ಇಂಟರ್ನಲ್ ಎಲ್ಲ ಕೇಳ್ತೇನೆ ಇವನ್ನ. V2 square equal to Vm2 square plus Vu2 square. Vm2 square equal to V2 square minus Vu2 square. ಇದು ಈಚೆ ಕಡೆ ತಗೊಂಡೇನ್ರಿ Vm2, ಇದು Vu2 ಈಚೆ ಕಡೆ ಹಾಕೊಂಡೇನಿ. ಓಕೆ, ನಾವು Vm2 square. Okay, next Vm2 square, Vr2 square, outlet velocity triangle in the from OBC. This is OAB. Now from OBC, Vr2 square equal to OB square plus BC square. OB square means Vm2. BC square is what you can write as U2 minus Vu2 whole square. You can write like this, Vr2 square. Now Vm2 square is equal to Vr2 square minus U2 square plus Vu2 square. I have expanded it, A minus B whole square minus 2 U2 Vu2. I have expanded like this. Name it as equation 1. Name it as equation 2. Now equating 1 and 2. From 1 and 2, from 1 and 2, equating those things. From 1 and 2, equating 1 and 2. So V2 square minus Vu2 square is equal to equating 1 and 2. So ಎರಡು equate ಮಾಡ್ರಿ, V2 square minus Vu2 square is equal to Vr2 square minus U2 square plus Vu2 square minus 2U2 Vu2. That is okay. Okay, this much I think you are understood. Now further we will simplify it. Further, let's name this equation as 3. equation as 3. Or else, wait for before. Okay, now this is the equation you are formed. Now we will solve this. I will get this 2v2. 2u2 v2 I will get this outside. Okay, this one I will get this. So 2u2 vu2 is equal to ಇದನ್ನ ಈಚೆ ಕಡೆ ತಗೊಂತೀನಿ ಉಳಿದಿದ್ದೆಲ್ಲ ಈಚೆ ಕಡೆ ಹಾಕೊಂತೀನಿ vr2 square minus u2 square minus vu2 square. I will take these v2 and vu2 to the right side. Minus v2 it is minus here. Minus v2 square minus v2 square plus vu2 square. These two will get cancelled. Here minus sign is there, so you can write as u2 vu2. This becomes plus v2 square. This becomes minus vr2 square. This becomes plus u2 square divided by 2 divided by 2. Similarly, from inlet velocity triangle IVT, you can write as u1 v1 vu1 is equal to v1 square minus vr1 square, okay, plus u1 square divided by 2. Similarly, you can write like this. Now from Euler's energy equation, I will write as this equation as 3, this equation as 4. Now these two velocity triangles are not necessary for me, so that I am clearing. Now from Euler's energy equation, you know that E equal to joules per kg. This one I am using, or else E naught. This equal to V u1 minus V u2. Substitute 3 and 4. Substitute 3 and 4. Substitute 3 and 4 here. Okay. Substitute 3 and 4 in 5. In 5. Substitute it. E naught, that is energy, that is joules per kg, is equal to, after substitution you will get 1 by 2. I will take common. Okay, v1 square plus u1 square minus vr1 square, vr1 square, okay, minus v2 square minus u2 square plus vr2 square will get like this, will get like this. Okay. After rearranging all these things, 1 by 2 v1 square minus v2 square plus u1 square minus u2 square u2 square plus vr2 square minus vr1 square. Okay, this is the alternative form of Euler's equation for power generating machine. It is very important and useful expression. This is for power generating machine, E generation I will write. And you can write also for power absorbing machine. For power absorbing machine, all these things will get reversed. That's it. 1 by 2 v2 square minus v1 square plus u2 square, this is square, minus u1 square plus vr1 square minus vr2 square. This is for power absorbing machine. This is for power generating machine. Any doubt is there till this? Okay, I have only less than 1 minute. The first term is the kinetic energy change in absolute velocity. Second term is the kinetic energy change in the tangential velocity. Third term is the kinetic energy change in the relative velocity. Okay, these are the things you should learn. And thank you one and all. This one I will explain later once again, this significance, and this derivation will be asked in the examination. Okay, it will be very important one. Thank you and all.
Thank you.